Welcome to the deep dive. Today, we're plunging into a topic that, well, it's often out of sight, out of mind, but absolutely critical for our safety and environment. Hazardous waste management.
Hmm.
It's far more complex and rigorously regulated than you might imagine. Impacts everything from huge industrial plants down to, the air we breathe and the water we drink.
Absolutely. It touches almost everything.
So our mission for this deep dive is really to pull out the key bits of info from the sources, take you on a journey through the main definitions, the really powerful regulations, and the surprisingly detailed ways it's all controlled.
Yeah.
Think of it as your shortcut to really getting what hazardous waste means and maybe more importantly, why it's managed the way it is.
And what's fascinating, I think, is we're looking at a system that's designed to protect us on multiple levels. From the specific chemical properties of just one substance all the way up to broad community awareness. We'll connect the dots on how everything from, say, a small chemical spill to a big abandoned industrial site gets addressed under this legal framework, a framework that's really evolved quite a bit over time.
Okay, so whether you're prepping for a big meeting, just incredibly curious, or maybe you just want to feel more informed about a really vital part of our modern world, get ready. We're about to unpack some seriously interesting stuff.
Definitely.
All right, let's unpack this then. When we talk about hazardous waste, it's obviously not just about tossing something in the bin. There's this incredibly robust legal backbone that kind of dictates every step. Could you start us off? Walk us through the main federal laws that set this whole system up.
Absolutely. So the foundational federal law in the U.S. is the Resource Conservation and Recovery Act, RCRA. That was enacted back in 1976.
FCRA 76, okay.
Yeah. Before RCRA, waste disposal was often just, well, a dilute and disperse kind of mentality. Just
Yeah.
spread it out.
Right, hope it goes away.
Exactly. RCRA changed all that. It shifted to a contain and control approach. Its main goal is protecting human health and the environment from the hazards of, well, current and future waste disposal.
Contain and control, that sounds like a massive shift. What's the sort of core mechanism RCRA uses for that?
Well, the cornerstone concept, the really big idea under RCRA is what's known as cradle-to-grave management.
Cradle to grave. Heard that term.
It means RCRA set up this manifest system. It meticulously tracks hazardous waste right from the moment it's created.
The cradle.
The cradle, exactly. Through all the transport, any treatment it gets, temporary storage, and then finally, its ultimate disposal, the grave.
Gotcha.
It's a complete life cycle management approach, ensures accountability every single step of the way. And beyond that, RCRA also sets specific standards for all the places involved, the generators, the transporters, and what are called treatment, storage, and disposal facilities, or TSDFs.
TSDFs. Okay. So RCRA handles the active, ongoing stuff, preventing new problems. But, we know not all problems are new. What about the legacy stuff? Past industrial practices, maybe those abandoned sites just sitting there, sometimes contaminating communities.
Yeah, that's a huge piece of the puzzle, and that's precisely where the Comprehensive Environmental Response, Compensation, and Liability Act, CERCLA, comes in. That was 1980.
Circling.
Okay. Most people know it as Superfund.
Ah, super fun. Right.
Yep. This act specifically tackles the cleanup of those existing abandoned or historical hazardous waste sites, the ones posing significant risks.
Okay, but how does Superfund actually work? I mean, cleaning up massive contaminated sites sounds incredibly expensive. And often the original polluters might be long gone, right? Or the companies don't exist anymore.
It is incredibly expensive, you're right. So Superfund established a trust fund, hence the name Superfund, to pay for cleanups when the responsible parties couldn't be found, or maybe just couldn't pay.
Okay, so there's money.
There's money, but crucially, it also created a strict liability standard.
Strict liability. What does that mean exactly?
It means that parties identified as responsible could be held accountable for cleanup costs regardless of fault, even if what they did was technically legal at the time they did it,
Wow.
regardless of fault.
Yeah. It was a critical legal innovation, acts as a powerful deterrent, and a strong mechanism for ensuring accountability, even decades later. It's a stark reminder in environmental law that a company's past actions can literally haunt its balance sheet for decades.
That sounds incredibly powerful. Maybe a bit controversial, too. And like a lot of major laws, it probably didn't just stand still, did it? Did Superfund get updated or expanded?
Yes, it did. The Superfund Amendments and Reauthorization Act, we call it SARA, came in 1986. It reauthorized CERCLA and it significantly expanded it.
Okay, Sarah 86. What was the big addition?
A really important addition with SARA was Title III. That's the Emergency Planning and Community Right to Know Act, or EPCRA.
Community right to know sounds important. It is. This part requires facilities handling hazardous chemicals to inform local communities about the types and quantities they have on site.
Ah, so transparency.
Exactly. It's a vital step towards empowering local residents. Gives them info about potential risks right in their backyard. Lets them participate in emergency planning.
That's huge for safety and awareness, moving from just cleanup to like proactive info sharing. Okay, what about the people actually doing the cleanups and responding to emergencies? They must be exposed to incredible risks.
Absolutely. Their safety is paramount. And that brings us to OSHA. Specifically, OSHA 29 CFR 1910.120, it's the Hazardous Waste Operations and Emergency Response Standard, or HAZOWOPA.
Haswoper.
This standard specifically protects workers doing cleanup ops at hazardous waste sites and also those first responders dealing with hazardous materials, spills, and emergencies. It's all about ensuring their safety in really dangerous situations. Requires extensive training, safety protocols, protective gear, the works.
You know, reflecting on all these laws, RCRA, Superfund, SARA with EPSIRA, HAZWOPER, it's really quite something. How many layers of protection society's tried to build?
It is.
What's really insightful, I think, is how each law isn't just a rule, but it's like a layer of response to past failures, right?
That's a great way to put it.
RCRA was like, okay, let's stop making new messes. Superfund was society facing up to its, industrial past. And then EPRA and HAZWOPER seem born from hard lessons about what happens when communities and workers are kind of left in the dark.
Exactly. It's a living system, constantly learning and adapting based on experience, a testament to environmental accountability, really.
Okay, so with that legal foundation laid, the obvious next question is, how do we actually apply these laws? How do we say definitively, okay, this stuff is hazardous waste and that stuff isn't? It can't just be someone's opinion, right?
No, absolutely not. It's definitely not a guess, and that's a critical point. The identification process is very specific under RCRA. First step, a material has to be defined as solid waste. Only then can it potentially be classified as hazardous waste.
Okay, solid waste first, then hazardous.
Right. And there are two pathways for that hazardous classification.
Two pathways. Okay, what's the first one?
The first involves what we call listed wastes. The EPA maintains these specific lists of wastes that are just known to be hazardous based on experience or testing.
So they're pre-approved as hazardous, basically.
Pretty much. These lists cover basically two main categories. Waste from specific industrial processes. Those are known as the F&K lists.
F&K lists, okay.
And then there are discarded commercial chemical products, pure chemicals that have been thrown out. Those fall under the P and U lists.
P and U. So industrial process and discarded chemicals.
Right. Think of it like knowing the usual suspects from certain industries versus catching a specific pure chemical that's been tossed. If your waste matches one of these descriptions, boom, it's hazardous. No further testing needed in that case.
Okay, that makes sense for known stuff. But what about, I don't know, new chemicals or unique waste mixes that maybe don't fit neatly onto those lists? Does the system catch dangers that aren't already categorized?
Precisely. And this is where it gets quite interesting. If a waste isn't on one of those specific lists, it can still be considered hazardous.
Wow.
It can be hazardous if it exhibits one or more of four specific hazardous characteristics. These are what we call characteristic wastes.
Four characteristics. Okay, very specific. Can you lay those out for us?
Sure. First, there's ignitability. Pretty straightforward. Does it pose a fire hazard? Think flammable liquids, certain solvents, waste oils.
Right. Catches fire easily. Got it.
Second is corrosivity. Does it have the ability to corrode steel? Or does it have a very high or very low pH? Think strong acids or bases that could, eat through containers or skin.
Okay. Burns or corrodes? What are the other two?
The third is reactivity. Reactive wastes are unstable. They might explode or maybe generate toxic gases when mixed with water or under certain conditions. They could undergo violent chemical changes.
So unstable, potentially explosive, dangerous stuff.
Very. Think of a volatile chemical that, if mishandled, could violently react. It's the kind of unpredictable hazard that, it keeps emergency responders on high alert.
Yeah, I bet. Okay, and the last one.
And finally, toxicity. This means the waste contains certain concentrations of specific toxic chemicals that could potentially leach out into groundwater if it's improperly disposed of.
Leach out. So seep into the environment. How do they test for that?
There's a specific lab test for this. It's called the Toxicity Characteristic Leaching Procedure, or TCLP.
TCLP.
And the insight here isn't just that there's a test, but that this specific test is designed to simulate the harsh acidic conditions you might find inside a landfill.
Ah,
Yeah, it tries to predict how readily those toxic components might actually escape into the environment in a real-world disposal scenario.
That's incredibly detailed.
Mhm.
Really trying to make sure nothing dangerous slips through the cracks, and even predicting how it might behave later on.
Mm.
Okay, so once we identify something as hazardous, either by list or by characteristic, are all generators treated the same?
Mhm.
Or does the amount of waste they produce change the responsibilities?
That's a crucial distinction and a really important question for anyone handling these materials. RCRA regulations vary quite significantly based on the amount of hazardous waste a facility produces each month.
Okay. It's not one size fits all.
Not at all. There are two primary categories for generators, and these categories dictate their compliance obligations.
Okay, what are those categories? What's the difference in scale?
The first are large quantity generators, or LQGs. These are facilities producing 1,000 kilograms, that's about 2,200 pounds or more, of hazardous waste per month.
1,000 kilograms. 200 to 200 pounds. How much is that visually?
Think roughly 5 full 55-gallon drums. That's a fair amount.
Okay, that's an LQG. What's the other main category?
Then we have small quantity generators, or SQGs. They produce between 100 and 1,000 kilograms per month. So that's about 220 to 2,200 pounds.
Between one half drum and 5 drums, roughly.
Exactly. And there are also very small quantity generators, sometimes called conditionally exempt, with even fewer requirements. But LQGs and SQGs are the main ones that trigger significant regulatory oversight.
So it's not just hazardous or not, it's also how much hazardous.
Yeah.
What does that mean for their actual responsibilities? Are the rules dramatically different for an LQG versus an SQJ?
Oh, absolutely. These categories determine a generator's specific responsibilities for pretty much everything, from how long they can store waste on site to the manifesting requirements, that's the cradle-to-grave tracking we talked about.
Right, the paperwork.
Yeah, the detailed tracking. It also affects employee training requirements, the extent of their emergency planning, lots of things. If you connect it back to the bigger picture, it ensures the level of oversight, the stringency of the rules, directly matches the potential risk posed by the volume of hazardous waste being handled.
Makes sense. Proportional responsibility.
Exactly.
Okay. So we've defined what hazardous waste is, and we understand that responsibility scales with quantity.
Hmm.
Now, the big question, how do we actually manage it effectively? Is it just about, finding a place to dump it?
Absolutely not. And this is where the management hierarchy becomes so important. Effective hazardous waste management focuses on this tiered hierarchy of controls. And disposal, that's actually the least preferred option.
Use preferred. That's interesting, because I think most people, when they think waste, they think disposal,
Yeah.
trash can, landfill.
Right. But the goal here is different. This hierarchy isn't just about environmental protection, though that's key. It's often about smart economics, too.
Okay, so if disposal is the last resort, the bottom of the pyramid, what's the very top? What's the most preferred option?
The most effective approach, right at the top, is waste elimination and minimization.
Eliminate it. How?
Basically, prevent the generation of waste in the first place.
Okay.
You can do this, for example, by substituting non-hazardous materials for hazardous ones in your processes, or maybe redesigning the industrial process itself so it inherently produces less waste, or implementing really detailed waste reduction plans, improving operating practices, just being more efficient.
So designing out the problem before it even starts.
That's the ideal, yes.
Yeah.
Stop it at the source.
Okay, that makes sense as the best option. But what if you can't eliminate it entirely? What's the next best thing?
Next down the hierarchy is reuse, recycle, and reclaim.
Okay, finding another use for it.
Exactly, finding beneficial uses for waste materials. This prevents them from ever needing disposal. Think about things like reusing solvents, maybe in a closed-loop system where they get cleaned and put right back into the manufacturing process. Or participating in waste exchange programs. Sometimes one company's hazardous waste can actually become another company's valuable raw material.
That sounds like a win-win. Good for the environment, maybe good for the bottom line too. Are there, strong incentives or regulatory pressures pushing companies towards this?
Oh yeah, both. The cost of disposal is itself a huge incentive to avoid it, but regulatory frameworks often mandate exploring these reuse and recycle options first. It's about shifting that mindset from a linear take, make, dispose model to something more circular.
Makes sense. Okay, so eliminate, then reuse, recycle. What if you can't do those?
Then we move to treatment. If you can't reuse or recycle it, the next step is often to treat the waste to make it less hazardous or maybe even non-hazardous before any final disposal.
Treating it. How does that work? What kinds of treatment?
There are several methods. For instance, physical treatment. Things like solidification or encapsulation. Basically, locking the hazardous components into a solid block or matrix so the harmful chemicals can't easily leach out.
Okay, trapping it.
Right. Then there's chemical treatment. Things like neutralization, maybe adjusting the pH of an acid or a base to make it less corrosive.
And I imagine biological methods, too, using nature's processes.
Precisely. Biological treatment. This uses microorganisms, bacteria, fungi, to break down certain organic wastes into less harmful substances, often used for contaminated soils or water.
Interesting.
And then there are specific detoxification processes. These are engineered specifically to remove or neutralize the toxic properties of a waste, aiming to transform it into something benign. The goal is always reduce the hazard before it reaches its final destination, if it has to have one.
Okay, so if all those options, elimination, reuse, treatment, fail, or they just aren't feasible for a particular waste, then and only then do we get to disposal.
That's the idea.
But I'm assuming even disposal isn't just, digging a hole. It must be highly engineered and regulated, too.
Oh, absolutely. Disposal is the final step, the last resort for waste that can't be managed any other way. And even here, there are highly controlled methods. Well, one common method is secure landfills, and these are definitely not your typical town dump from 50 years ago.
Right.
They are highly engineered facilities. They have multiple layers of impervious liners, robust systems to collect any liquid that's called leachate that might form to prevent it escaping into the soil,
Leachate collection.
and continuous groundwater monitoring wells all around the site to detect even tiny leaks. They're designed to contain the waste safely for, well, centuries, ideally.
Wow. So a lot more complex than just digging a hole. What other disposal methods get used for hazardous stuff?
Another method is incineration. High-temperature burning can safely destroy many types of organic hazardous waste. Breaks them down into simpler, less harmful compounds like carbon dioxide and water.
But burning hazardous waste sounds like it could create air pollution issues.
It could, which is why it's crucial that these incinerators have advanced air pollution control devices. Things like scrubbers and filters to thoroughly clean the emissions before they're released into the atmosphere. Very strict regulations on that.
Okay. Any other main methods?
Well, there's also deep well injection. This involves pumping liquid hazardous wastes into deep, isolated geological formations, far, far below any groundwater source.
Pumping it underground.
Yeah. However, it's really important to note this practice is now heavily restricted by the EPA. There are significant long-term risks and environmental concerns associated with it, so it's much less common than it used to be.
Okay. That hierarchy really shows a systematic, almost philosophical approach, doesn't it? Moving from prevention first all the way down to these highly controlled, engineered disposal methods as the very last resort.
Exactly.
It's a far cry from just dumping it somewhere. And it really speaks to the significant scientific and regulatory effort involved in trying to safeguard our environment and health from these really challenging materials.
It does. It's a complex problem with complex solutions.
So we've taken quite a deep dive today. We've uncovered this intricate world of hazardous waste management, from RCRA's comprehensive cradle-to-grave rules and Superfund's power to clean up the past, to the really precise ways we identify waste by its characteristics, and finally, that layered hierarchy of controls, all designed ultimately to protect the planet.
You've definitely got a solid understanding now of how this complex web of laws and scientific processes works together, trying to safeguard both human health and the environment. And, what's fascinating here, I think, is just how much ingenuity goes into managing materials we often just think of as trash.
Yeah.
It transforms a potential ecological disaster into something controlled, something manageable, hopefully, which raises an important question, doesn't it?
Go on.
Well, what other waste streams in our daily lives, maybe things like just regular household waste or plastics, which are a huge issue, could benefit from applying a similar kind of innovative hierarchy, really pushing to transform problems into resources or even eliminate them altogether instead of just, burying them or finding somewhere else for them to go.
That is a truly thought-provoking question for all of us to mull over. Where else could we apply this prevent first thinking? We really hope this deep dive has given you a fresh perspective, made you feel well-informed about a topic that, it literally underpins our modern industrial society.
Hope so.
Keep digging into the details, keep asking questions, and we'll catch you on the next deep dive.